A highfalutin mathematical word, the new word for today is called a function. Excuse me. A function simply is this. Basically, and we'll get more into this later in your mathematical lives here, is a rule where you put one number in, which we call the input number, and then you get one number out, which is called the output number. It's kind of hard to find, a little easier if you look at some things here. For example, the book gives the surface area of a cube. Surface area of a cube. Have we done surface area?
No.
Then why would the book give us this thing here? Let's say you've got a cube. Do you know what a cube is? Sure, why not? Do we know what surface area is? Nobody knows what surface area is?
Area of the surface.
Why is this the example that they give us? Well, surface area is the area of all the sides added together. What do you know about a cube? A cube is a special type of prism. It's a square prism. What do you know about a cube? A dice that you roll, Jaden, it is? It has 6 sides, and what do you know about all 6 sides? They are all the same. So if I want to find the surface area of a cube, and I know one side, what would I do to find the surface area? Let's say this cube is a 2 by 2 cube. What's the area of this front side? And what's hard? Riley says 4. Well, if every side's area is 4, what's the area of the whole thing? Riley?
24.
24. So surface area for a cube is 6 times the area of the side, which we'll just put as 6 times A. This, children, is a function because it is a rule. Whatever the area is for one side, I multiply it by 6 and I get the surface area. So let's say the area is, let's say it's a, let's say it is a, here, let's make a little table. Not one that you sit at, but let's say this is the surface area of one side. Area of one side. Let's say, and this would be my input number. We already did 2. We know the area of one side when it's 2 is 4, and the surface area was 24. What if the area of one side was 9? What if it was a 3 by 3 cube? What would be the surface area of the shape? Well, you take the rule. 6 times 9 is, Emily? 54. What if it was a 4 by 4 cube? Well, area of one side is 16. If you have 6 of those, the math is getting hard now. 16 times 6, anybody going once, going twice? Isabel?
96.
96. Should we do one more? Let's do one more. A 5 by 5. Area of one side is 25. 6 times 25, Elijah?
150.
It's like having 6 quarters is a buck and a half, yeah. So this is your function, and this is the table. And guess what? I could take that one step farther, and I could actually graph that. Okay, I could actually, well, I'm gonna blow it up so I can graph it in a little bigger thing here. If I were graphing this, we've graphed things before, right? It's gonna be kind of goofy because it's not gonna look right. This is the x number, this is the y number, like we've plotted the point 424. Yes, no? 424 would look like this, 1, 2, 3, 4, and then 24 would have to be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. What if my cube had a side of 1? What would its area be? 1. And what would its surface area be? What's 1 times 6? 6. So here at 1, 6, 1, 2, 3, 4, 5, 6, I put a dot. And what if my cube had a side of 0? What would its surface area be? Now that's a hard one. Jaden? 0. So it would go right here. So then if I graph this, I could connect my lines and it would look like that. That's utterly amazing, isn't it? Not really, don't say that. It's not going to be that goofy. I'm not sure why they picked that example to do, but let's look at a different one. Here's one out of the book they're going to give you. They might give you a table that looks like this. And they will tell you that these are the x numbers, and the function is 3 times x minus 2. Okay, here is what it'll look like. They might tell you that x equals 2, 3, or 4, and they want you to find what the output number is. This is the input. You put this input number in here, do the math, and see what you get for the output number. Well, if I have 3x minus 2, if I put 2 in for x, what is 3 times 2?
6.
And then subtract 2 from it, you get
4.
4. Or then change it for the second one. Instead of putting 2 in for x, I'm going to put 3 in for x. What's 3 times 3?
9.
Minus 2?
7.
7. Or this time I put 4 in for x. 3 times 4 is
12.
minus 2 is
10.
10. And this is a little function table that you have there. And that's all. A function is just nothing more than a goofy sort of rule. I don't know if it gets any. They might ask you to make the rule. Do you think they'll do that? Maybe not. Well, here's one. Take a look at this one. This is an example from the book. And the table might look that way. The table might go this way. And they might give you the x and the y up here. Check out this one. What if this was what the table looked like? 3, 1, 5, 3, 6, 4. What would go here? What would be your rule? Or what would be the function? Okay, this is your input. This is your output. Okay. What do you have to do to the x number to get to the y number? So it look like this. Y equals, what do you do to the x number to get to y? Brianna? Right, so how would I write that? Y equals whatever x is minus 2. So what would my answer be here for 10? I know it's hard, but 10 minus 2 is, the lady? 8. Or what if I put 15 there. 15 minus 2 is? 13. So they may give you the table and ask you for the rule. They might give it one way or the other, but I think you're pretty smart people, right? And time is fleeting us by. All right, for tomorrow.